Welcome to section 05. Today we're going to talk about adding probabilities. And here's our vocab to start off the section. The first one is probability. That is a measure of chance that is a given event E will occur. We write that as P of E, so the probability of an event happening. A probability model is a mathematical model used to represent the outcomes of an experiment. A uniform or a simple probability model, that's used to describe an experiment for which all outcomes are equally likely or have the same probability of occurring. And there's two different types of probability that we're going to be talking about. We've got theoretical probability, and that's the probability of an event occurring based on the sample space of outcomes. And experimental probability is the probability of an event occurring based on the trials that have been performed. Few more vocab terms here. We've got a simple event, an event that has a single outcome, such as rolling a 6 on a die. A compound event, a problem consisting of two or more events, such as rolling a 6 or a 3 on a die, so there's two choices there instead of just one. And then finally, mutually exclusive, events that cannot occur at the same time. Okay, so the first thing we're going to talk about is theoretical probability. So to find theoretical probability, we take the number of favorable or desired outcomes and we divide it by the total number of possible outcomes. Okay? So the way I've always done it is it's want over could. So what do you want to happen? How many times could that happen? Over how many things could happen. Okay, so how many do you want to have happen over how many could happen? Okay, experimental probability is the number of times that the event actually occurred over the number of trials that were done. So that one, experimental probability is what actually happened. So the number of times that the event actually occurred over the total number of trials, whereas theoretical probability is what should happen over what could happen. Okay, so the first question is, what is the theoretical probability of rolling a 6 on a die? Okay, so that is again a want over could problem. So how many ways is there for what we want to happen to happen? Well, we want there to be a 6, and there's only one 6 on a die. And what could happen? Well, there are 6 sides, so 1 over 6. That's the theoretical probability of rolling a 6. So now the next one, what's the experimental probability of rolling a 6? You'll notice on the side here we've got these trials. So we rolled a die 10 times, and this was the results that we got. We got 1, 1, we got 2 2s, we got 1 3, we got 1 5, and we got 5 6s. Okay, so the experimental probability of rolling a 6 is how many times we actually rolled a 6, which was 5, over the total number of trials we did, which was 10. 5 over 10, that would simplify down to 1/2. So theoretical and experimental probability of the same exact event don't necessarily have to be equal to each other. Some addition rules for probability. So if we want two events, A and B, and we know that they're mutually exclusive, which again, mutually exclusive means they can't happen at the same time, and we want the probability that either A or B will occur, we would take the probability of A happening plus the probability of B happening. Now, if those same two events are not mutually exclusive, and we still want to know whether A or B will happen, we still take the two probabilities added together, but then we need to subtract the probability that they both happen. Okay, up here we didn't have to worry about that because they were mutually exclusive and there wasn't any overlap. But here, since they're not mutually exclusive, we have to account for them both happening at the same time. So when we get to the problems that we're going to be asked to do and we're going to be adding probabilities together, the first thing you have to do is you have to figure out if the events are mutually exclusive or not. And then you would use the corresponding formula once you've figured that out. Okay, so our first example, Keisha has a stack of 8 baseball cards, 5 basketball cards, and 6 hockey cards. If she selects a card at random from a stack, what is the probability that it is a baseball or hockey card? Okay, so the first thing we need to do is we need to figure out if this is mutually exclusive or not. Okay, so can she draw a card that is both baseball and hockey? No, because it's either baseball or hockey. So these are mutually exclusive. Which means to find if we've got baseball is A and hockey is B, if I want to find the probability of A or B, I would just take the probability of A plus the probability of B. So the probability of A, or a baseball card being chosen, there are 8 baseball cards, and there are a total of 19 cards, because 6 plus 5 plus 8. Probability of B, so the probability of drawing a hockey card is 6 over 19. So the probability of A plus the probability of B would be 8 over 19 plus 6 over 19, which would give me 14 over 19. That would be the probability of drawing a baseball or hockey card. Okay, our next example, suppose that of 1,400 students, 550 take Spanish, 700 take biology, and 400 take both Spanish and biology. What is the probability that a student selected at random takes Spanish or biology? So to help you out here, we're going to say that that A is going to be take Spanish, B is going to be take biology. So the first thing you need to do, figure out if these are mutually exclusive or not. So is it possible to take both Spanish and biology at the same time? Once you've figured that out, you use the correct formula and then get an answer. So I want you to pause the video, get an answer, and then go ahead and hit play and see how you did. Okay, so the first thing that you should have noticed is that they're not mutually exclusive, especially since right here it says that 400 kids took both. So that right there should tell you that Spanish and biology can be taken at the same time, since 400 students did that. Okay, so we need to use the formula probability of A plus the probability of B minus the probability of both. So the probability of A, so take Spanish, is 550 Spanish takers out of a total of 1,400. So 550 over 1,400. Probability of B, 700 took biology out of the 1,400, so 700 over 1,400. And probability A and B, there was 400 that took both, so my probability would be 400 over 1,400. Now, I did not simplify any of these fractions because I'm going to be adding and subtracting them together, and it's important that my denominators are the same, and they already are, so I shouldn't do anything with them. So if I plug them into my formula, I should have 550 over 1,400 plus 700 over 1,400 minus 400 over 1,400, and that should get me a total of 850 over 1,400, which, if I take a 50 out of the top and the bottom, I can simplify it down to 17 over 28.